All right, so today we're looking at target 5. We're looking at composition of functions. Composition of functions is basically a function within a function. So in this box right here, it gives kind of a nice definition and as some notation as well. And I think notation sometimes is what trips us up the most. So we read this as g of f, or in this case, g of f of x. This is also read g of f of x. So that doesn't say gof, it's not gof, it's g of f, which is the same as g of f of x, which is the same as that third notation. And so you can see here, when you're doing a composition, you kind of work from the inside out. So you've got one function, in this case f of x, inside another function, g of x. All right, so let's look at some examples. So for a, I'm doing g of f of negative 2. So I'm going to start at the inside and I'm going to find f of negative 2. So this means I'm going in the f function, and wherever I see x, I'm replacing with negative 2. When I do that, I get 4. So now I'm going to write g of 4, because I'm replacing f of negative 2 with 4. So now if I do g of 4, I'm going to the g function, and wherever I see x, I'm replacing it with 4. And then I simplify that, and I get 1. So g of f of negative 2 is 1. Take a second to try b, then we'll check in and see how you did. All right. So again, we're going to start with the innermost part. I'm going to find g of negative 2. That's telling me to go into the g function, and where I see x, replace it with negative 2. That simplifies to negative 5. So now I'm going to find f of that value, negative 5, which is saying go into the f function, and where I see x, replace it with negative 5. And that would give me a positive 25. So notice these problems were the same, but the order was different, and notice I get 2 different answers. That's what this is referring to. It's not commutative. Commutative means the order matters. So like 2 plus 3 gives me 5, just like 3 plus 2 gives me 5. So addition is commutative because the order doesn't matter. Composition is not commutative because we can see here the order does matter. We get different answers depending on which order we did. All right, so now let's look at C. So now we're doing g of f of x. So I'm still doing the same thing, but instead of finding f of a value, I'm just using the whole function. So this is saying go to g, and where I see x, replace it with f of x, which was x squared. So now I'm going to go to the g function, and where I see x, I'm going to replace it with x squared. Okay. So I can't simplify that, so that's my final answer. If I look at D, I'm doing f of g of x. So g of x is x minus 3. So that's telling me to go to the f function, and where I see x, replace it with x minus 3. So when I square that by either using the pattern or double distributing, I'm going to get x squared minus 6x plus 9. Okay, let's look at number 2. Computer Store offers a 5% discount off the list price X for any computer purchased with cash. At the same time, the manufacturer offers a $200 rebate for the computer. Write a function f of x to represent the price after the 5% discount. Okay, so a couple different ways you could do this. You could say, well, I'm going to take the price, which is x. 5% as a decimal is 0.05, so I'm going to do minus 0.05x. So that means I'm going to take the price of the computer, and I'm going to subtract away 5% of the price of the computer. The other way of thinking about this is if I have 100% that I'm paying and I have a 5% discount, I'm really paying 95% of the price. So if you want, you could write that as 0.95x. And notice in this first function I wrote, if you simplified this by combining like terms, you would get this 0.95x. So they end up being the same equation. Okay. Now I've got g of x, and I want that to represent the price after the $200 rebate. So that would be taking the price and just subtracting $200. All right, write the composition f of g of x and explain its meaning. So I'm going to work from the inside out. So I'm going to do f of g of x, which is that. So I'm going to go into the f function, and wherever I see x, I'm going to replace it with x minus 200. Okay. So this composition means that I will first get the $200 rebate, and then get the 5% discount. Okay. For D, if I do it the other way, g of f of x so I'll have 0.95x minus 200. So in this case, it means I'm getting the 5% discount first, and then I'll take that and get the $200 rebate after the 5% discount. That does say rebate, I swear. There we go. So that's target 5, composition of functions. It basically means we're taking one function and putting it inside another function.